Greetings to all. Today I am going to present the topic of Wein bridge oscillator. There are three types of feedback oscillator that use RC circuit to produce the sinusoidal outputs. There are Wein bridge oscillators, phase shift oscillator, twin T oscillator. Generally, RC feedback oscillators are used to frequency up to 1 megahertz. Among the Wein bridge oscillators, the most widely used for because of simplicity and stable sinusoidal output. So, the feedback circuit uses lead lag oscillator network. The R1 and C1 is the lag portions and R2 C2 is the lead portion of the circuit. The lead lag network is determine the oscillation frequency. Let us understand the operations of lead lag network. At the low frequency, the lead network is dominated because the reactance of capacitance C2 is high. As the frequency increases, the reactance of C2 decreases, allowing the output voltage to increase. At particular frequency, the lead lag becomes the dominated. Due to the decreasing reactance C1, the output voltage starts decreasing. Therefore, the output voltage reaches its maximum value at the specific frequency. It's called a resonance frequency. The resonance frequency is given by a equation Fs equal to 1 divided by 2 pi Rc. When R1 is equal to the R2 and C1 is equal to C2. At resonance frequency, the phase shift through the circuit of 0 degrees and attentions for the feedback network is 1 to 3. The conditions is oscillations, sustained oscillations. This slide shows the basic Wein bridge oscillator circuits. The lead lag network is the positive feedback loop, selects the particular frequency. The negative feedback is loop contains a voltage divider. This voltage divider sets the amplifier gain to compensate for the attenuations in the feedback network. Thus, the circuit is acts as the non-inverting amplifier and frequency selective feedback. The next one is gain requirement. The closed loop gain is the non-inverting amplifier is given by gain is equal to 1 plus R1 divided by R2. Since the positive feedback is attenuated the signals by the 1 to 3rd, the amplifier gain must be exactly 3. The compensators for the signal loss, the unity gain condition to achieved when R1 is equal to 2 times of R2. This ensures the continuous oscillations. To iterative oscillations, the initial closed loop gain must slightly greater than 3. This allows the signals volt up from noise. After requirement amplitude is reached, the amplifier gain decreased to exactly 3. As a result, the total loop gain became unity and sustained oscillations are maintained. One method of maintaining sustained oscillations used back-to-back Zener diodes. Initially, the Zener diode have behaved like open circuits. This increased the amplifier gain. The small noise signals are simplified this continuously. The output voltage is gradually built up when the output voltage is reached to Zener breakdown voltages. The Zener diode is conduct and the amplifier gain reduced to 3. Thus, the stable oscillations are obtained. So, automatic gain control necessary to maintain the loop gain of exactly 1. Although the Zener diode method is simple, it is introducing distortions because of the nonlinear characteristics of the Zener diode. A better approach is used to JFET as a voltage controlled resistor. This method produces stable and low distortions sinusoidal waveforms. Operating with a small or zero drain source voltage works in the ohmic region. As the gate voltage is increased to the drain source, the resistance is also increases. If JFET is connected to the negative feedback path, the automatically control from the achieving big houses of resistance changes with the voltage. This helps to maintain the constant output amplitude. The gain and control using JFET. The gain of control operation amplifier is controlled by the components on the circuit, including the JFET. The drain source resistance depends upon the gate voltage. Initially, when there is no output signal, the gate voltage is 0. The resistance is the minimum and the loop gain is become the greater than 1. Oscillations begin the build up to rapidly. As the output signal is increased, the negative output signal is forward bias diode D1. The capacitor C3 is the negative voltage. These negative voltages increase the JFET drain source resistance. As a result, the amplifier gain decreases and the output amplitude stabilizes. With the proper compound and selected the gain remaining the required value, the JFET responds quickly. Since the operative ohmic region it is behave the variable resistance, if the output amplitude increases, the drain source resistance increases, reduce the gain, the output decreases, the resistance decreases, increase the gain. Therefore, the JFET is automatically compounded for the output variations and maintain the stable oscillations. Overall, they conclude the Wein bridge oscillator is widely used for RCA capable of stable sinusoidal waveforms. Then uses of automatic gain technique, especially the JFET, improves the waveform's quality and ensure the sustained oscillations. Thank you.